let's look at something called arc length. Arc length is when we're looking at a circle and we have this angle cut off here, and this angle is going to be what we consider theta, and we want to know the length of this arc. So it's part of our circumference that is associated with a certain angle. Okay, now this angle can be obtuse, it can be acute, different things like that, but it's associated with this particular angle. Now obviously it's going to change based on the radius, because it's going to change based on that circumference. But again, I want to know what is the measurement of this right here. I don't want to know what the measurement of the entire circle is, or this entire circumference. I just want to know this little bitty piece. It's kind of like when you are looking at a square, what's the measurement of that one side type of thing. I want to know what the measurement of this one little bitty arc is based on this angle. And so we look at it, and arc length is usually denoted with the lowercase l. And so we have L is equal to the circumference times theta. Theta is the angle in degrees divided by 360 degrees. So it's telling us what part of this entire circle it is. So remember that circumference is pi times our diameter times our angle divided by 360. So we could look at arc length as pi times diameter times our angle all over 360 is what we're basically looking at. Okay? So here we want to find the length of a 72 degree arc of a circle with a radius of 25 centimeters. So if I look at this circle, which is a horrible looking circle, and my radius is 25 centimeters, and let's see here, my angle here is 72 degrees. I want to know what the length of this right here is. So we have the arc length is equal to pi times the diameter. Now I don't know what the diameter is, but I do know what the radius is. It's 25, so I have 2 times 25 times my angle, which is 72, all divided by 360. Now 2 times 25 is 50, and then 50 times 72 is going to give me 3,600 all over 360, and that's 3,600 pi, because I still have my pi. I take 3,600 divided by 360, and I get 10 pi. Or if you want to do an approximation, that would be 31.4 centimeters is the length of this arc. Now, we want to find the radius So here we have this circle, and we have this central angle here that is 120 degrees. We know the arc length right here, from here all the way to here, is 31.42 miles. That's a pretty long ways around the circle. We want to know this. We want to know the radius. So we know that length is equal to pi times the diameter, or 2 times the radius, times the theta, or the angle, divided by 360. Okay, we know what the length is. It's 31.42. I'm going to go ahead and put 3.14 in here, times 2, times r, times 120, divided by 360. So 3.14 times 2 will give us 6.28, times 120 will give us 753.6, divided by 360, and that has a pi on the numerator, or I'm sorry, that has an r on the numerator, not a pi. And we have 31.42 sitting out here. Now to solve for r, we're going to multiply both sides by that denominator. So I'm going to multiply both sides by 360. That will eliminate our denominator. So that will leave me on the right-hand side with 753.6 times our r. And on the left-hand side, it will leave me with 11,311.2. And then we've discussed this in an earlier video, that in order to get rid of this and get the r by itself, we're going to divide both sides by the 753.6. That way it will only leave me with that r, or my radius. And so the radius is approximately 15 miles. And I do say approximately for the simple fact we use 3.14. Okay? So you do have to do a little bit of algebra equation solving here. So you just have to be careful with the order of operations and everything.